So started recording now. So let's continue from here. We want to look at our previous class. We learned several solutions to O.D.E by variable separable and by integrating factor. But now we want to look at solutions to O.D.E if the problem are given in terms of words. How do we solve it? Now let's go. They said, given that after the recent expansion of production facilities of Malta Guinness in Guinness Nigeria PLC Lagos, the beverage production is growing at a rate that is proportional to the production of the brewery. Now, look at that statement. They say what? The beverage production is growing. If I want to represent the growth of this production, I'll say dPdt. This is like the growth rate altogether. The rate at which the production is growing. Right? They said the rate is proportional. Yes. How do you mean?
Yes, 100%.
They said that what? The rate is proportional to the production. dPdt is proportional to the production. Okay? That is the rate at which the Malta Guinness are being produced is proportional to its production. And don't forget, whenever proportionality sign, whenever it changes to equal to, we always have dPdt equal to what? I will introduce a constant KT altogether.
Yes.
Good, KP rather. What was there was P, so I'll say KP. Good. Okay, again, let me explain that part again so you get it clearly. So if you observe, they said, given that after the recent expansion of production facilities of Malta Guinness in Guinness Nigeria PLC Lagos, the beverage production is growing. That is, the beverage production, they said it is growing at a rate that is proportional to the production. Now, what is the rate of the production? You see, when you are talking about rates, we are measuring with respect to time. So the rate of the production is what? dPdt. They said the rate of this production is growing at a rate that is proportional to the production. So here is proportional to P. And don't forget, whenever we change proportionality sign to equal to, we will always introduce a constant. So I have an equal to Kp. That's what I go from there. So our K is constant. K is constant. So let's go from there. You see, before we move to this other part of the question, let's just quickly solve this differential equation. This is a differential equation now. So now, what method will I use to solve this? We all know that it will be variable separable. I can separate my variable. I can put this P under here to become dP over P equal K dt. If I bring this dt here and I bring P here, this is what I'll be having. That's variable separable. Then from there, I will integrate both sides. I will apply integral sign to both sides. Now, pay attention. If I integrate, what's the integral of 1 over P? If you have something like this, integral of 1 over x dx, remember is what? Ln x. The next exactly. So therefore, this one also will be what? Ln P. Ln P. Nice. Ln P equal to what? Kt. This one is just what? If you integrate dx, the answer is what? X. Okay. X. So you integrate dt, the answer is just t. That's I have kt, then plus c. So let me say this is my constant. Are we together?
Yes.
Yeah, this is my constant. So let me call my constant C1. So that's how. So as we have solved this thing now, pay attention. This type of solution, if you observe, this type of solution, what do we call it?
General solution.
Exactly, general solution. Why? It has arbitrary constant. In fact, let me even tell you, I can rewrite my solution this way. P equal exponential kt plus c1. How? Whenever this link go to the other side, it will go and carry everything here with the power of e. So what I'm having here can be written as e to the power of kt times e to the power of c1. Law of indices. This is like multiplication. So therefore, I'll be having something like this. P equal to, you see, I can just say, let this e goes to power c1 be equal to c, constant c. Therefore, I'll be having P equal to what? C exponential. I'm coming. I can say, let my exponential C1 be equal to this constant C. Therefore, my solution will now be P equal to what? Everything here now is now what? C.
C.
Well, because all of them are constant, so E raised to power KT. So this is a general solution now. So this type of solution is what we call general solution. Why? It's a solution that contains what? Arbitrary constant.
Constant.
Solution that contains arbitrary. Now, let us now go back to the question now. So the question says that what? If the production in year 2000 was 2 million, are we together? Was 20 million rather.
Yes.
Okay, you see what happened? I'll do something like this. That year 2000, I will call it the base year. Are we together? Let me say year 2000. Yeah. Year 2000, I want to call it the base year. Base year means that, okay, I'm taking it at time t equal to 0. Are we together? Hello, are we together?
Yes.
So at time t equal to 0, they said that the production was 20 million cartons. So at time t equal to 0, production was what? 20 million cartons. So let me just put 20 million. Okay, 20 million. Nice. So therefore, if I just substitute these two inside this solution, what will I be having? I'll be having what? I'll be having 20 million equal to C. Have you now?
Yes, E raised to power 0.
E raised to power 0. Have you now? And E raised to power 0 is what? 1. Therefore, my C equal 20 million. So my C equal what? 20 million. So therefore, I can write this solution now as P equal, my C is now 20 million. So my C is what? 20 million C, 20 million exponential KT. What do you observe from this side? You observe that our general solution has now changed to what we call what? What type of solution is this now?
That's changed to a particular solution.
Particular solution. Thank you very much. This is a particular solution. Now, before we have what we call general solution, after substituting what we have here, we now go what we call what? Particular solution. Nice. Now, we have gotten that. So they now ask us another question again. Now said that what? And in year 2010, it was 22 million cartons. So in year 2010, now pay attention. Base year is 2000, sorry. 2000. So year 2010, it means that I'm looking at time t equal to 10. Have you now?
Yes.
That's 10 years interval. From 0 2000 to 2010, that's 10 years interval. So they said the production was how many? 22 million. 22 million. So therefore, let us put it there. So what do we have? 22 million equal 20 million exponential KT. If you look at this thing now, million cancels million. So I have 22 over 20 equal to exponential what? KT. Our T here is 10, don't forget.
Yes.
So times 10, good. Exponential what? 10K. So what I'm having here is E raised to power 10K equal 22 over 20. If I bring this here, I'll be having what? You will see. If E comes here, it become 10K equal to ln 22 over 20. Are we together?
Yes.
When the exponential come, it become ln. Yeah. So I have what? K equal to 1 over 10 ln 22 over 20. Are you a calculator with you there?
Yes, on this calculator.
Good. Okay,
One,
but yeah, going to get some. Just tell me, what do you get?
Ln 22 over 20. 9.5 times 10 raised to power minus 3. 9.53 times 10 raised to power minus 3.
Exactly. So I can just say, okay, let me just, so it's like 0.0953. Have you now?
Yes, exactly.
Good. So that's what I have. That's my key. So that I can write my solution also as P equal 20 million exponential 0.00953C. So that's what I have. So actually, they now ask us one final question. What the final question? The final question is this: that what? Estimate the production of the brewery in year 2030. That year 2030 is how many years interval? Like from the base year, 30 years, exactly. 30. From year 2030, our T equal 30 30. So what do we have? They asked to find P. Therefore, P equal 20 million. Our 20 million is how many zeros? 6 zeros. Have you now?
Yes.
Exponential 0.00953 times 30. So what do we have? Final answer? We'll be having 2 points, sorry, 26.62 million cartons. That's it.
$26.62 million. Yes,
Yeah,
yes.
exactly. That's just the concept. Don't worry, like, I don't want us to spend much time on all this, but the more we see, we'll be solving them. Just take note of this one so I can move on. You understand?
Yeah.
Uh-huh. So we have learned that. Now, the next thing for us to look at is now this. We have looked at integrating factor. So the next thing for us to now look at, I'm coming. I want to see the word problem and also, okay? We have done integrating factor. Now, the next thing I want us to look at is how to solve this type of differential equation that will be going away from more than one order. For example, check something. You see, I want to discuss something we call D operator. D operator. D operator D is given as D. You see this D operator here, pay attention. Wherever you have D over dx, this we denote it as D. This is what we call the D operator. Are we together?
Okay.
Good. So let me now say I have D square over dx square. That's equivalent to what? D square. Are we together?
Yes.
Also, wherever I have D cube over dx cube, I will also have what? D cube. You see, there's something interesting about the D operator is that D operator obeys, like, it can be handled the way we normally handle our x, y, and z. Are you there? Like the way you always handle our x in a variable in normal mathematics, the way we can add together, subtract together, all those stuff like that. It obeys what we call commutative law of addition and so on. Like, don't worry, when we are solving, you will see. You will see. Let us just pick a question. Look at this differential equation now. If I have a differential equation like this, let me say I have a differential equation like this, that let me say I have 3 d cube y over dx cube plus 2 d square y over dx square minus dy dx plus y equal to 0. Can you put this in terms of D operator?
Yes.
Can we put this in terms of D operator? Yes. Don't forget, you see, D cube over dx cube. So, you know, I have 3 here. This D cube over dx cube is same thing as capital letter D cube. Have you now?
Yes.
So I'll be having 3D cube. Then plus 2. What is, sorry, remember that there's y here. Don't forget. There's y here. I'll add the y here. 3d cube y. Nice. Then plus 2. You see this d square over dx square is the same thing as what? D square. Have you now?
Great. Yes.
So this y minus. What's d over dx? D over dx is d, exactly. Then remember I have y, dy plus y equal to 0. Remember, something is common to all of them, y. I can divide through by y. I'll be having 3d cube plus 2d square minus d plus 1 equal to 0. You see this thing now? It is like a cubic equation in polynomial. So I can solve this thing the same way I always solve normal polynomial in mathematics. That's what I mean by what that d operator. We can do it like normal x and y. Are we together?
I get. I understand.
Nice, good. So let us now use this D operator to now solve some question. Like, we want to use it to be solving differential equation. Now, pay attention. Now, okay, I'm coming in. Now, How do we now solve this differential equation? Okay. Now, I'll teach you how to solve. That is solving. I don't want to give you the concept and no story. Solving homogeneous DE. Exactly. Solving what? Homogeneous DE. Solving homogeneous DE. That is this one like this now. Look at this. D square y over dx square minus 5 dy dx plus 6y equal to 0. Now, see, we want to solve this homogeneous O.D.E. Are you together?
Yes.
We can observe that this is homogeneous. Okay, number one, you see that this is equal to 0. And we don't have any product of x and y. So this is homogeneous. Now, pay attention to something. Let me now show you the concept of solving this type of differential equation is that. Firstly, put it in terms of the operator. Are we together?
Yes.
If I put down number one, you observe that this one becomes something like d square. Remember, there is y there, right? Minus 5 dy plus 6y equal to 0. And y is common to all of that. We're saying d square minus 5d plus 6 equal to 0. Do you understand what I did here just now? I'm following this pattern. This same pattern, all I'm following. Nice. Now, after this, you see, next one I'm going to do is that I'm going to solve this quadratic equation. I'm going to solve this quadratic. You see this equation I got here now. Let me tell you the concept like this now. This equation is what we call characteristic equation. Characteristic equation. Isn't that what this step in solving homogeneous O.D.E is that what? Get the characteristic equation. You can see if it is second order, third order, and so on like that. The first thing to get the characteristic equation. How do you get characteristic equation? You put the type of D operator, cancel out the Y. What you have here is your characteristic equation. So let us solve this quadratic equation. If I solve the quadratic equation, I'll be having something like D minus 3. I mean now.
Yes.
D minus 2.
D minus 2 equals 0.
So therefore, D equal 3. So these are the roots of the equation. Now, pay attention. You see, there's a particular rule I will give you. There's a particular rule I will give you to obtain the general solution for this O.D.E. Remember, look at this root. This root that you are seeing here, they are real and distinct. What did I say? They are real and what?
Real and distinct.
Distinct means that they are different from each other. They are different roots and they are real numbers. They are different roots and they are what? And they are real numbers. Now, whenever you obtain something like this, see the way your general solution will be. Therefore, your general solution is not the y equal. I'll tell you something now. See, C1 exponential 2x plus C2 exponential 3x. C1 and C2 are constant. This will be your answer. Now, focus. Look at this place. Let me assume that you have some differential equation to solve, and you have some roots to be, let me say, M1 and M2. And this M1 and M2, they are what? Real and distinct. Now, pay attention. What will be the general solution? It's easy. Just say your y equal was C1 exponential M1x plus C2 exponential M2x. Your answer, put them on this exponential, add x, then C1 and C2. That's it. Do you get it?
I get.
Yeah. So whenever you solve any other one, in fact, okay, let me even extend this thing now. Let me say you solve the differential equation and you get the roots to be M1, M2, and M3 to be the root. Let me say it gave us a cubic polynomial. We now solve to get M1, M2, M3. How do we get the solution? We say, okay, the solution of y equal to, what do we do? C1 exponential what? M1x plus C2 exponential what? M2x plus 6 exponential what? M3x. Do you get that?
Yes.
Exactly. That does it. That's when you get real and distinct. You know that if we solve the equation, we can get real and distinct roots, we can get equal roots, we can get complex roots. I will give you all the cases here.
I want to ask a question.
Okay,
So,
no, I'll ask.
yeah, the question is order of arrangement, does it matter? Like
Does
now
not matter.
the
Yeah. Your 3 can come in, your 2 can come in. Does not matter at all.
all right.
Yes, does not matter at all. Yeah. I just love to arrange from smallest to biggest, just to have a pattern.
That's not.
Good. Now that's for that one. Okay. There's another one again that you can have. Okay, let me solve another problem. Look at this type of question now. Number 2, we have to solve this problem. Y prime prime plus 3y prime minus 18y equal to 0. Then I give us something like this. Y of 0 equals 0 and y prime of 0 equal to minus 1. So this is what we call initial value problem, IVP. This type of problem is what we call what? Initial value problem. They'll be giving you initial conditions like this. If you observe, we call it initial condition. Why? Let me just quickly tell you this thing. You still meet it though. We are only checking at x equal to 0, same here at x equal to 0, same place. We call it initial value. But assuming we check at x equal to 0 here and x equal to 1 here, we call that boundary problem. Are we together?
Yes.
Let's go. Let's solve this special equation. Remember, if this notation is confusing you, you can write it as, okay, d square y by dx square plus 3 dy dx
dx
minus 18y equal to 0. So using the operator, I have d square y plus 3 dy minus 18y equal to 0. Then from here, what do we have? Divide through by y. What do you have? D squared plus 3d minus 18 equal to 0. Now, we'll now solve this quadratic equation. What I'm having is like 6 and minus 3. Yeah, so d plus 6, d minus 3, I think. Yeah.
Minus 3. Yes, yes.
Therefore, answer was d equal to 3 and d equal minus 6. This is our solution. So let us now write our, what will now be our general solution now? So the general solution would be what? Y equal to what? Don't forget C1 exponential. I like starting with small number, minus 6x. Or should we change it? There's no problem. We'll get the same thing. Okay, which one do you want us to write first? This or this?
Small number first.
What's a small number here? But it does not mean
that.
You get the same answer. Yeah, I just like to use it that way. Okay, see my general solution now. But we are not done. They give us some boundary value here that was at y equal to 0, at x equal to 0, y. You see, this thing means that, let me help you and write this in another way. This thing means that y at x equal to 0 equal to 0. That's it, as x equal to 0, y equal to 0. Yeah. At x equal to 0, y prime of x equal minus 1. So what you will do here is this. Check it out. I won't tell you how to use this initial problem. You see, when you get this thing, find the y here, that differentiate this thing to get y prime. What do we have? How do we differentiate exponential function? How do we differentiate exponential function? It is what? Minus 6 exponential minus 6. Do you remember this stuff?
Yes, yes.
You will differentiate the upper one. You have minus 6, put it here. So you can give minus 6c1 exponential minus 6x. This is of plus 3 6 exponential 3x. All together?
Yes.
Oh yeah, now let us now follow our pattern. Now check. Oh yeah, they said at x equal to 0, y is 0. Oh yeah, at x equal to 0, what do we have here? This one will be raised to power 0, 1. Raised to power 0, 1. I'll be left with c1 plus c2. c1 plus c2 equal to, what is my y? My y is equal to what? 0. Aha. Now what equal to 0? Equation 1. Also, next one, at x equal to 0, you know, this one is y prime. You are going to substitute this one. You substitute it here. Don't mistakenly substitute it to this second place, okay?
Yes.
At x equals 0, now put x equal to 0 here. What do you have? We have minus 6c1 plus 3c2, then equal to what? My y prime. Equal to what?
Minus 1. Minus 1.
Minus 1. Then this is equation what? Equation 2. Next, what do we now do? We now solve this equation simultaneously. Now, simultaneous equation. Now, I want to multiply this equation by what? Let me say by 3. Are we together?
Yes.
I'll be having 3C1 plus 3C2 equal to 0. Let me call this one equation 3. Now, let's solve these two equations simultaneously now. These coefficients are the same. Minus 6, what do we have? Minus 9C1, this is 0, equal to minus, have now?
Yes, therefore C1 is equal to 1 over 9.
1 over 9, thank you. So if C1 is 1 over 9, if I substitute it here, C2 will be equal to what? Minus 1 over 9. Have now?
Yes.
Nice. So that's what I have. So I have those. So what will not be my solution now? What do I have there as my solution? How do I not get my particular solution now? Now you see, it's easy to get now. If I substitute all my boundaries here, remember that this is my general solution. Now I've gotten C1 and C2. So why will be equal to what's my C1? What's my C1? 1 over 9. Have you now?
Yes.
What's my C2? Minus 1 over 9.
Minus 1 over 9.
So you can see general solution, particular solution. It's simple, Abi.
Yes.
So the case that I've solved here now, these are the case of real and distinct roots. These are the case of what? Real and distinct. So what you have learned from here now is that whenever you have a real and distinct root, the general solution to this homogeneous O.D.E is what? Look at it. Is this. Have you now?
Yes.
Also, if it is more than this, this is it. And so on like that. It continues that way. So this for real and distinct root. So we will now check other pattern. There are some other pattern. What of if it is not real and distinct? Okay, let us check for repeated roots. For repeated roots. For repeated roots. That is, if you have equal roots, how do we deal with equal roots? Now look at this equation. You have to find the general solution of the differential equation d square y over dx square plus 6 dy dx plus 9y equal to 0. Solution. The first thing is to get the characteristic equation. Have you now?
Yes.
T operator. So I have d square y plus 6 dy plus 9y equals 0. You see, some people write it this way. Like they'll put brackets and put one y here, and they'll remove all this y. You know it's the same thing.
Yes, yes.
Okay, so therefore, our characteristic equation was d square plus 6d plus 9 equal to 0. And what I'm having here is d plus 3 equals 0. So my answer is d equal minus 3 twice, right?
Yes.
Nice. D equal minus 3 twice, sharp. It means that what you see, the case of what I'm having here is what we call what? Real and equal roots.
Repeated.
Yes, equal or repeated roots, yeah. Real and repeated root, or it's a real and equal roots. That real must be there because minus 3 is a real number. Because there's a case for complex numbers too. Now,
okay.
Yes, so see what we have here now. So see what we have here, real and equal roots. So how do we solve for real and equal? Now watch, look up here. If the roots are m1 and m2 and they are equal to each other, let me call them m. In this case now, m1 and m2 are the roots and they are equal to each other. Therefore, the general solution to this will not be what? Y equal to, check, it will become C1 plus C2x exponential mx. That's all. You see the way we combine this constant. I'll say C1 plus C2x, then exponential, that common one, put it there. That is it. Wait, let us apply this thing. Let us apply it here. What will be my general solution?
Y will be
I'll
equals
still make
to
it clear. Y equal to, what do you have?
C1 plus
C1 plus
C2x
C2x,
exponential
exponential.
minus 3x.
Yeah, in fact, some textbook will use A and B. This C1 and C2, you can use whatever you want. Okay, let me now assume that if the roots are M1 equal M2 equal M3 equal M, what of if there are 3 equal roots? How do we do it? It's simple, same way. You say, check, you say Y equal to, you observe the pattern now, C1 plus C2x plus C3x squared
X squared
exponential mx. Do you understand?
mx. Yes.
Oh yeah, if there are 4 roots, how do I do it? Oh yeah.
C1 plus C2x plus C3x squared plus C4x cubed exponential mx.
Exactly. That's the pattern. That's the pattern. That's the pattern, exactly. So look at this one also. They ask us to find the general solution. Question next. Okay. All together.
Yes, yes.
Now let's go.
Nine d squared.
Okay, now let's go. So let us now write our characteristic equation. So I will go straight to the point. I have 9d squared minus 6d plus 1 equal to 0. Do you see that?
Yes.
So if I solve, remember, quadratic equation, this is 9. 2 numbers to give me 9. And when I add them together, I have minus 6. What are they?
So
minus 3 and minus 3. I mean,
yes. No.
Yeah. Minus 3 times minus 3 is plus 9. Minus 3 plus minus 3 is minus 6. All together?
Yes. But I think the root will be 1/3.
Exactly. Yeah, I'm coming. I want to show you one trick. The number I'm multiplying to give me this is minus 3 minus 3. When I add them together, I have minus 6 sharp. Then because so change their sign to be 3 and 3. Then divide them by this coefficient here, which is 9. So over 9 over 9. And that's 1/3, 1/3. So therefore, our D is equals to 1/3 twice. Or you can just use a calculator to run it. No one is checking on this one. So now I have this. This is the repeated roots. And how do you write the general solution? So the general solution, y equal what? C1 plus C2x.
Yes, exponential 1/3x.
Exactly. Okay, nice. Okay. That's for repeated roots. Okay, let's look at one more on complex roots. Yeah, complex roots. Okay, look at this question. So you have learned how to write for distinct roots. And you have real and distinct roots. You've learned how to write real and equal roots. And what you are learning now is what? Complex roots. Complex roots. Now look at this equation. Okay, let me just say, pay attention. Let me just say something. Now, for complex, let me discuss it here. If you solve a differential equation and your characteristic roots are complex roots, now pay attention. Let me say the complex root is, let me say the first guy. Don't forget, one thing about complex roots is that, let me say you are solving a quadratic equation and your first root is alpha plus I beta. Don't forget that what the second root will be the conjugate of this complex number, which is alpha minus I beta. Do you remember that fact?
Yes.
You are solving a quadratic equation, you now get a complex number. If the first guy is this, the second root will be the conjugate. So it means that if you are having a complex root, which is alpha plus or minus I beta, it has put these three together. Therefore, what will be the general solution? The general solution will be what? Now pay attention to what y equal what will it be? It will become exponential alpha x, open a bracket, c1 cos beta x plus c2 sine beta x. This is it. This is how it will look like. Okay. This is how it will look like. Jot it down. I'll be using it now.
Yes.
So if you observe, the solution we are solving are homogeneous differential equation. Why? You observe that the right hand side are equal to 0, equal to 0, equal to 0. Have you now?
Yes.
Yeah, this is what you go and perfect very well. Our next one will be the one that is not homogeneous. That one you now be looking at solution by method of variation of parameters and measure of undetermined coefficient. Those are the two you'll be looking at, because we have many methods of solving it too. But according to this course you are taking, you are required to know two ways, which is method of variation of parameter and measure of method of what? Undetermined coefficients. And those methods are used to get what we call particular integral. When we get there, let's solve question on complex roots. Now, look at this question. Let's look at question on complex roots. Look at this. I have d square y over dx squared plus 4 dy dx plus 13y equal to 0. Now, solution. Characteristic equation, d squared plus 4d plus 13 equal to 0. You observe this cannot be factorized. So I'll say d equal minus b plus or minus square root of b squared minus 4ac all over 2a. Quadratic form. You know?
Yes.
So when you solve this, you'll be having, let us solve it. Like, what do you have here? 16 minus 4 times 13 will give us what? That's 52.
Yes, 52.
Yeah, over 2. So I have d equal minus 4 plus or minus square root of this will give me minus what? What do you have?
It will give you 52 minus 16.
Is that 36? I mean, what is that? I'm coming.
36, yes.
36.
Yes.
I'm coming, please. Minus 36, 9. So this is what we have. Then all over 2. Now do we now get this one? Say minus 4 plus or minus this I. This is square root of a negative number. This is a complex number I. Square root of 36 is 6, right? All over 2. So I have minus 2 plus or minus 3i. Have you now?
Yes.
So if you observe, remember I told you now, I have a complex root now. This is a complex root, which is minus 2 plus or minus 3i. Now check, it's like this alpha plus or minus I beta. Have you now? So like here now, alpha is minus 2, my beta is 3. So how am I going to leave my solution? Don't forget, I'll leave and say that what? My general solution will be what?
E raised to power minus 2x.
E raised to power minus 2x. C1 cos 3x. Have you now?
3x, yes.
Sine
C2 3x.
Simple. That's how to solve it. It's not hard at all. You get? Okay. That's everything. Now, since you have idea of everything now, okay, let me now say, I now solve a differential equation that have third power. And let me say my roots, m1 is equals to, let me say m1 equal to minus 2. m2 is equal to m3 is equals to, let me say 4. How will you write the general solution? One of them is Now, one of them is just a single root. Why the other two are repeated root? It's simple, don't worry. Now, check it out. It will be y equal to, now check. This one is just a single root. So C1 exponential minus 2x. Abi now, that's simple, Abi.
Yes.
Nice. This one now repeated root. How do we undo repeated root? Don't forget, it will be like C2 plus C3x exponential 4x. Do you see that? This pattern is what we use to undo repeated roots. All together?
Yes.
Exactly. That is it. Okay, let me now say that, okay, we solve another one. We now have something like M1 equal to, let me say 3. M2 is equal to minus 2 plus or minus I. Sorry, minus 2 plus I. And M3 is equal to minus 2 minus I. One is a real root, while the other are complex root. How do we solve it? Now, pay attention. You see the right general solution. Y equal to, this one is what? C1
exponential 3x.
There's no problem here. But this one, how do we undo complex root? Don't forget, exponential minus 2x. Have you now?
Yes. C1 cos x
plus C2
sine x.
So, that's it. So that's it. So it means that since you have known this one, that this assignment will not be hard. So you are going to solve this assignment. This is your assignment. You are going to solve this one. You'll be able to get it easily. Y prime 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 minus 6y prime prime plus 2y prime plus 36y equal to 0. Sharp. So our next class is that tomorrow, Abi?
Yes, that will be tomorrow, sir.
Then we are going to be looking at the one without, or if you want us to do maybe statistics or this one, it depends on you. Maybe prepare the timetable and just see.
Okay, there's no problem. I'll prepare the timetable.
Yeah. But you've not told me the money for statistics. So maybe you want to give me for free.
Let us talk down once. Wait, let me stop the recording now. Let's talk about that one.
Okay.